Okay students, so next we will do question number 30. After that we'll move back to question number 20, 21 and 22. Okay, and then rest will be in similar question. You can also do it. So 21, it's little bit different. Try to listen carefully that question. Once you understand that, rest of the question you can solve it. Okay, now see this question. Find the value of a and b. Now to find the value of a and b, what you need? Two equation, right? First thing that come to your mind must be, I need two equation now, okay, for a and b, such that the function, now to get the equation there must be some information, right? So what they have given, such that the function defined by this fx equal to this, okay, wait, I have not written, is continuous function, they have said. Okay, they have given this one, fx is a continuous function. Now since they have said it's a continuous function, this function will continuous at all point, because they didn't mention any particular point here, right? So this function will be continuous at all point means what? This the graph of this function will not break at any point. Okay, so from this information, can I make two equation of a and b? Let's see. Now see here what they have given, fx equal to 5 when x is less than or equal to 2. Means in your graph, if you take x 2 or less than 2, your graph will be what? 5. Y will be always 5. So it will be something like this, straight line till 2. Okay, and next they have said if x is greater than 2, less than 10, then the graph will be ax plus b. Your equation will be this one, right? Ax plus b obviously will represent a linear equation somewhere like this or like this. Now since they have said continuous, we know that it will not break at 2. So say, let's say that the graph will be this one, suppose. Okay, now see at 2 it does not break. That's what the meaning, right? Next, if x is greater than 10, when it will be greater than 10, the graph will be 21. So from there again it will be a straight line. 21 at length 21, it will be straight line like this. It will go on. It will go on like this, okay, from 21. So at 21 and 2, we know that the graph will not break, and rest, so it's obvious, right? It will not break. So can I make two equations from here? Obviously yes. At 2, we know the graph will not break. So can I write at 2 x equal to 2, left hand limit is equal to right hand limit is equal to f of 2. Can I write? Yes. So from this, can I make equation of a and b? So you can see left hand limit, what it will be? Limit x tends to 2 minus f of x. 2 minus means less than 2. Less than 2, this is the function, so 5. Right hand limit, limit x tends to 2 plus. 2 plus means greater than 2. Just greater than 2 is ax plus b is equal to f of 2. F of 2 means x equal to 2. What is the function? 5. So from this, obviously this is constant, so where you will put x, right? So this will be 5 only. Next 2, if I put here, we will get twice of a plus b. Directly I can put, right? It is a determinant value is equal to 5. So from this I can make one equation. What is that? 2a plus b equal to 5. So you mark it as 1. So one equation we got it. Another equation we need. Now see, at 10 also we can check, right? At 10 also we know that the graph will not break. So at x equal to 10, I hope you have understood why I am taking 2 and 10 only. In the last videos, if you have watched, we used to discuss continuity at this point only, breaking point only, because rest will be, obviously it is continuous. This will be continuous. Less than 2 obviously continuous. The chances is at 2 graph might break, because you can see different function, but in this case it will not break. We are confirmed with that. Why? Because they have said fx is continuous function. So continuous means it will not break for sure. Okay, I don't have to check that one. So at 2 the graph will start like this from here after 2. Okay, this graph will start like this, something like this. Okay, it might go like this also, we don't know that, and we don't need also. Okay, so from 10 again it will be continuous like this. 21 it says y equal to 21 always, so it will go straight from here like this. Okay, so at 10 and 2 we know the graph will not break, right? So at 10, left hand limit is equal to right hand limit is equal to f of 10. So left hand limit, what it will be? Limit x tends to 10 minus f of x. 10 minus means less than 10. Less than 10 is ax plus b. Ax plus b is equal to right hand limit. Limit x tends to 10 plus f of x. Now 10 plus means greater than 10. Greater than 10, what is the function? 21 only. Direct constant value. Next, f of 10 equal to 10. What is the function? Same, 21 only. Right, so from this can I get an equation? So 10, if I put here in place of x, 10a plus b is equal to this. You can write 21 only, right? So this and this same, 21. So this I got one equation. So equation 1 and 2 easily you can solve. You can see b is there, so elimination method you can use. Using elimination method, okay, from elimination method from 1 and 2, we get what? Elimination method, what you will do? 2, this 2 minus 1, it's better, right? Why 2 minus 1? You can say 2 is bigger than 1. You can take 1 minus 2 also, no problem. So 10a minus 2a, how much? 8a. b minus b gone, 21 minus 5. Right hand side, 21 minus 5, 16. So a equal to how much? 2. So putting a is equal to 2 in which equation you will put? Let's put in 1. A equal to 2, if I put 2 into 2, 4. 4 if you bring this side, b equal to 1 you will get. So a equal to 2, b equal to 1 will be your answer. Okay, so this step is very important. Why we have taken this, you try to understand that. Okay, at x equal to 10 we have taken, and at x equal to 2 we have taken. Why we have discussed this one already in the previous video. I have already explained why we used to take at this point only continuous. Okay, next. Question number 20. Is the function defined by fx equal to x square minus sin x plus 5 continuous at x equal to pi or not? Okay, this question you can do like previous one only, but the moment I will show you question number 21, you can follow that way also this. Okay, 21 also you have to see well. So this, okay, you can do normally the way you have done previous question, because at x equal to pi they have asked you to check whether the function is continuous or not at x equal to pi. So what you will do, left hand limit you will find out, right hand limit, and then f of pi. So f of pi, when x equal to pi, what you will get? Minus sine pi plus 5. Now minus sine pi. Sine pi means how much it will be? 90 plus 90, right? 90 plus 90 means which quadrant? Second quadrant. Second quadrant, sine is positive, so its sine will come to be positive only. And since odd multiple of 90, this trigonometry ratio will change, right? So it will become minus, this will give you positive value only, so it no minus sign will come out, and then trigonometry ratio will change to cos, so it will be cos pi by 2. 90 better write down pi by 2 in radian form. Okay, so this will give you how much? Pi square minus cos pi by 2, it's 0 plus 5, so it will be how much? Pi square plus 5. So f pi you got this much. Then right hand limit and left hand limit also, if you get pi square plus 5, then your problem solved, right? So let's see, limit x tends to pi minus x square minus sine x plus 5. So can I put pi here? So if I put pi here, same thing you will do this only, right? So you will get pi square plus 5. Now see, in this case I have put pi, but actual definition is what? Limit definition is, we don't put exactly pi, we put which values? Those values which are on your left of your pi, close to it, right? So in your graph, suppose this is your pi, so close to pi, whatever values are there close here, those value we used to take it as x. Why I'm explaining this? Because this is how we are going to solve question number 21. So listen carefully. Actually we don't put pi here, this is just a shortcut through which we got this, right? Now in this case, that shortcut I will use it. I have put pi and got this one, but in question number 21 we cannot put that pi value directly, because that will be for general, for all value you have to check x equal to pi particular value here. They have said, right? in question number 21 they didn't mention you at x equal to that particular value. You have to check. You have to check for all x. When they say for all x, you cannot simply put pi here. Okay, why I will explain in the next question only. So in this case, meaning is what? Pi minus means I will put close to pi on your left, whatever value is there, I will put in place of x. I will put, suppose, in place of x, and we'll see what kind of fx you will get. Function value, what you will get. You will try to find out, you will see that it will tend towards pi square plus 5 only. That is what the meaning here. So we have written directly here, right? So in the next question, we are not going to write directly. I will explain you why. X pi plus this one also same pi. If I put it here, sin x plus 5, simply I can put pi here, right? Particular, only one value, so this will give you pi square plus 5 only, because when you put pi here, same calculation you will do right here also. So in this case you got this is equal to this is equal to this, right? Now this will be limit x tends to pi. Directly can I write f of x is equal to right your left hand limit and right hand limit. When we don't put any sign, we understand this is your general function, right? Left hand limit as well as right hand limit when your function exists. Okay, when your limit exists, I mean, then we used to write directly like this instead of writing minus plus. So you can understand when I write this one, left hand limit and right hand limit both are same, f of pi. So this is the definition of continuous function, right? You can write in this way or directly you can write f is continuous. F is continuous at x equal to pi. So at x equal to pi only we have checked this is continuous or not at all point. Now see question number 21. At all point we have to check whether it is continuous or not. So number 21. So number 21, what they have asked? They have asked you to discuss the continuity of this function. Now they didn't say at which point. Means what? All point you have to check. Right? So for all point, if I have to check, how I will start? Same, right? X, what you will take? A particular value we used to take, right? Fixed value. Remember in previous question when we have to find, for example, fx equal to suppose 2x, like this is given function. Then when you have to check continuity at this function for all value of x, then how you used to do it? X used to take it some fixed value, right? C, suppose general value we used to take, I can say. Okay, we don't take 1 or 2 or 3 because it's impossible, right? For infinite value 1 by 1 you cannot check. So we used to show it generally. So C, we used to take a particular fixed value. Now in this case, when we take fixed value left hand limit, what I will do? Limit x tends to C minus, we used to write f of x. Then we used to solve. How we used to solve? Limit x tends to C minus, then 2x plus 1 I have written. Now in this case, what we used to do? We used to directly put C, 2c plus 1. Why we used to put C directly? Because C, in this case, these values are what? Small numbers, right? In you can say real numbers. Yes or no? Now real numbers is confirmed that if I take x, some real number, you know what are the real numbers here, right? Less than C. Suppose 2. C is 2, suppose. Less than 2, you know what are the numbers you have to take. 1.9 you will take, 90 suppose, 1.99 you will take, 1.999 you will take. You know those values to take in place of x, right? And then you will find out fx. You can do that. For if you take C in place of C, suppose 3, right? If you take 3x, you know what you have to take in this case. I hope you can understand. C minus means I cannot put C directly. What I have to put? Less than C. So C, if it is 3, I have to put in place of x less than 3 values close to it. Those values I have to put, and I have to check what fx you will get if you take those values. Now when your x will tends to 3, your fx will tends to some particular value. Okay, that will be the answer of this one. Then when you will take C4, okay, then you will take here what value? Close to 4, whatever values are there. You know those values, 3.9, 3.99, those values you will take, and we'll check what kind of value the fx will tends to. You have to find that. Now in this case, you know what value to take, right? Less than that. But when it is sine of x, see carefully, if you take simply c, okay, simply c. Now these are angles, remember, okay. Then when you find out left hand limit, x tends to c minus, simply if you write down this, sin x plus cos x. Listen carefully. Question is very simple, but why we are going to take x equal to something fixed value we will take, but we will not take c, something else. Why we are taking, why we will take that value, that I'm explaining, okay. Now c minus, simply if I take fixed value c, suppose, now c less than c, suppose this is, suppose what value you will take, these are angles, right? Yes or no? So in case of angle, sine of this angle itself is very difficult to calculate. In this case fx, it will be very simple to calculate, simple expression. If you take 3.9, you know 3.9, if you put it simply, you can calculate this one. But in this case, this function itself is a complicated one. Now see, if I take fixed value, then less than c I have to take, right? Now those value, what it will be, that will be confusion here. In this case it was very simple. If c is 3, suppose, less than 3, we know what to take, 2.9, 2.99, we know all these values, so we can easily find out fx also. So that's why in this case, no need to put other than c. C fixed value, we can put it here in place of this, and we can directly find out 2c plus 1. But in this case, you cannot do like this, sin c plus cos of c. In this case, you cannot put simply c here. Why? Because we know that we have to put what values? Less than c, right? And then we have to check, as your x tends to that value, this function will tends to what value. Now that will be very difficult to calculate in this case. Fx in this case was very simple to calculate, because this was simple expression, but this is trigonometric function. So in this function, you cannot simply put c minus c in place of x and can write down sin c plus cos c, because this might change with different values, right? In this case, we know this is linear equation. If you put 1, then 2, then 3, the changes will be same, fx change. But in this case, you can't say. Okay, I know it's very complicated to understand, right? Now see, I will explain you why we used to take here, instead of c directly, we used to take c minus h for left hand limit. Now why minus h? Now see, in place of x, what value you have to take? I know it should be less than c. I hope this you know very well. We have done limit for many time, right? So I hope you have understood what value we have to take in place of x. C minus means less than c, we have to take close to c, okay. And we have to check, as those value which you will take close to c from your left, as you come closer to that means if it is 3, we used to take like this, 2.9, 2.99. Can you see, we are coming closer to 3. X, if you take like this, these values, then fx means this function also will tends to some value, okay. That value we have to find out, okay. So in this case, how we will check? X, we will take less than c. Now less than c, can I take like this in general form? C minus h is a very small number. Whenever we write this h, understand that this is a very small number, say 0.0001 like that, 0.002 like that, okay, very small number. Now see, if it is, for example, I'm taking 3, suppose, okay. See, if it is 3, what will be c minus h? 3 minus 0.1 will be what value? 2.999, like that value you will get or not? Close to 3. So in general form, x directly can I write like this? In this function, again I repeat, we don't have, this is fixed number, suppose 3. So when we find limit, we take c minus. C minus means, suppose this is 3, then 3 minus means less than 3 we used to take in place of x, right? Now in this case, we don't have to mention c minus h. For that 2.99, we don't have to mention minus h. Why? Because this is simple expression. We can solve. If you take 2.99 here directly, you can solve that value easily here, right? But in this case, those value if you take will be very complicated to solve. Like for example, if it is 3, 2.99 will be very difficult to solve here. Okay, so instead of taking here 2.99, what I have taken, I have given a general definition here for x itself. X, what we will take, instead of directly that same value, I will take c minus h, small number we have subtracted. Then what will happen? Already you have converted x into that small number. Okay, so I don't have to take now c directly. What I will take, and c minus means less than c, I don't have to take directly. I will take c minus h. This also meaning is same. Okay, so see what is the advantage of taking c minus h. It will convert into some identity and we can easily solve this one. Now whatever I have explained here, simply by listening you cannot understand. You have to listen and have to think yourself also what you actually used to do in limit. Okay, same definition I'm using. So instead of taking, suppose for fixed value we used to take, right, and you have to check for all value of x this function is continuous or not. So for all value it's impossible to find one by one, so we have to take in general form only. So x, in case of previous question we used to take directly c fixed value, and then we used to find out fx, right, will be continuous. In this case fixed value directly we cannot take, because when you take fixed value left hand limit, when you will find out c minus will create problem here. To solve it will be very difficult. So what we have done, we have converted x itself into that value. C minus whatever comes out, that value we have already converted. C minus h, this will be the number, right? Obviously C minus h will be a small number less than C, which will be very close. So this is also same, C minus small number 0.11001, like that number. So C minus that small number, if you do, obviously you will get that exact number here directly. So directly that we will put. Now this also we are putting in a general form. Okay, so basically what we have done here, you can understand from here. From I have taken one example here for a tabular form. Okay, suppose fx is equal to x plus 1 is a function, and I have to check continuity of this function at x equal to 2. Suppose, now how we used to check a limit, how we used to use like this, limit fx x tends to 2 minus, what is the value here we have to, the meaning of this one is what, as your x tends to 2 means come closer to 2 from your left. 2 minus means what, left means less than 2 values. From this side if you come close to 2, what fx will be, what fx will tends to, you have to find that value, right? So how we used to solve, actual method is this, x we used to take those value which will come closer towards 2. You can see 1.9, 1.99, 1.999, like this. It is coming closer to 2, right? Then if it happens x come closer to 2 like this, what your fx will come. So see, when you take x equal to 1.9, what is your fx? 1.9 plus 1, you used to take this value and used to put in the function value 1.9 plus 1, right? Next, this is the function. Okay, then when your x is 1.99, what is your fx? Fx will be 1.99 plus 1. So what you will get, 2.99. When your x is 1.999, your fx will be this one, is equal to 2.999. So you can see, as your x tends to 2, your fx is also tending towards some value. What is that? 3. So answer of this one will be 3. This is actual meaning, okay, of limit. Now we use shortcut here. Obviously we used to simply put here 2, because we know that this calculation was very easy. You have seen I can calculate also by putting 2. Instead of putting 2, I can do the actual method of this one. Instead of using shortcut. Okay, instead of using shortcut, I can use the actual method. But in this case it will be difficult. In this case what you will do, suppose x you have taken 1.99, what will be sine of 1.9? Itself it is very difficult, right? Sine of 1. This is your fx, sine of 1.99 plus cos of 1.99, what it will be? 1.999, what it will be? Sine of 1. So you cannot do the calculation here. It's very difficult in case of sine function. I hope you can understand. So simply, that's why we cannot use that shortcut also. In this case we used to use shortcut, right? 2 we used to put in place of x plus 1 will be function here. In place of 2 we used to in place of x we used to put 2 plus 1 3, we used to get this, because the tabular form is very simple to calculate in this case. But in sine function or trigonometry function, it's very difficult to proceed like this. Okay, so what we are going to do is these things which is there in your limit, this we will define in a different way. In this case, trigonometry function, we will define this one in a general form. Okay, so see, in case of trigonometry function, what we will do, if x is 2, suppose, what we have to take, 1.99, 1.999, like that we have to take, right? Here the values, yes or no? Now instead of taking like this, what we will do, we will take like this, 2 minus very small number, 2.0.00001, like this. Can I take like this? This will be general form. 2 minus 0, this will give you what? Very close value towards 2 or not? 1.99, yeah, I will take here 0.0000001, like this. Then what it will give you? It will give you 1.999999, like that it will give. Means very close to 2. In one step only I have written this instead of writing like this. I hope you can understand. So this value which I've taken, small number, instead of taking like this, we used to take h. 2 minus h. So in general form we have taken. So when we take this one in general form, what will be our fx? Fx will be like this, sine of 2 minus h, like this. Now this we can solve by using identity and all. So, trigonometry function, we can use identity and then we can solve it. Even for solving, suppose sine of 360, if I ask you to solve, what you used to do? You used to convert into some other function first, right? Yes or no? You used to simplify this one and convert into other function, you can say, or expression, and then you used to solve, because solving directly this one, it's very difficult. You know, graphically we have to solve this one. We have discussed this one in class 11. So basically what I want to say is, the way you used to follow in simple function, this function, the way you used to follow rules, exactly same way you cannot follow here in trigonometry function. So directly C, I cannot put it here and can solve it directly. So that's why we cannot follow this one. That's why we used to take, in place of x, directly we have taken, can you see, in place of x, what we have taken? 2 minus some small number, general form we have taken. Then your fx, what it will be, we will find out that by solving in the form of identity. Okay, so here what we will take, x itself we have taken c minus h. Okay, now c can be any real number, general one I have taken. Now c minus h, why I have taken? For left hand limit and right hand limit, to put the value directly. Okay, now see, one more thing. If you take x equal to c minus h, your whole function will convert into what? In terms of h. This is constant, right? This can change. This will be small number, means what? This can be anything, 0.00001, like that. So your whole function will depend on h now. Your variable, you can say, h. So when you write limit, it must be in terms of h only, right? Yes or no? So how you will write? So see here. So see here, h tends to what it will be. So see how to understand this one again. Now see, in place of x, what value I have to take? Very close to c, right? Very close to c means it must tends towards c. X must tends towards c. You have to take those values, right? Now when now this x will become what? C minus h here, right? We will change this one. We will substitute in place of x, c minus h, right? Now c minus h, when it will tends to, x tends to c means what? C minus h also must be tends to c, right? In place of x, when you will put in. Now c minus h, instead of saying x tends to c minus h will tends to c. When your h will tends to 0. Yes or no? Or you can you can solve this one like this also. In class 11 we have done, right? As your x tends to c, this will become c. Then what your h will become? H bring this side, c bring this side, it will become 0. So it means what? As your x tends to c, your h will tends to 0. Okay, and simply logically you can understand like this also. This must be what value? It must be those value which will be close to c, right? Close to c means this x must tends towards c. Now when your x will tends to c, when your h will tends to 0, if this will become 0, then only x will be c, right? So when your h will come closer to 0, your x will come closer to c. Okay, so instead of thinking like that directly, you can do like this. As your x tends to c, means if it becomes c, what your h will tends to? 0. Okay, so we will write h tends to 0. I know most of the students, they will memorize this one. Those who are taking tuitions and all also, I know they will memorize these things. But if you can understand this portion, obviously it will take time to understand this, but if you understand, continue to any problem, you can solve it. Okay, so sine c minus h cos c minus h. You can see this portion which we have defined here, we have already used here. As your h tends to 0, means come closer to 0, come closer to the 0, what this will become? Sine c cos c. Can you see the thing which it should come out? That will come out here only. I have solved it here itself. Okay, so what it will be? Limit h tends to 0. Now can I use identity here in these two cases? So okay, the video is getting a little lengthy, so I have just written it down. Okay, so this is becomes identity. What identity? Sine a minus b cos a minus b. Okay, so if you use this identity, sine a cos a minus sine b cos c cos a. Okay, that identity I have used in place of this one. Cos a minus b, what it was? Cos a cos b minus sine a sine b, right? So plus opposite sign, right? Sine a sine b. So this will be the identity. So use that identity. After that, put h equal to 0 and you will see sine c plus cos c you will get. So you might have seen that in this case we have already proved, instead of using tabular form, we have used that definition only in the limit. Okay, and we have find out the value. So same way, this is for left hand limit. Right hand limit also you find out. In right hand limit, what it will be? X, just put c plus h, because you have to put which values. When you will take tabular form, c plus something, you are greater than c, you have to take, right? So those value you take, that's why c plus h. So same way, you put c plus h in place of x and solve it. H will tends to 0, you will get sine c plus cos c here also. Then you find out fc, sine c plus cos c. Since all are same, f is continuous at all point. So you see this question and try to understand little bit. If you have any doubt, then tell me. Otherwise it will be difficult for me also what you have understood and what you have not, because I don't know whether you have cleared the thing in limit only or not, the previous questions and not. Okay, so if you are clear, I don't think you will face problem here also. Okay, thank you.